Well, that escalated quickly. All I'm trying to do is get my new CNC controller to work, and here I am with a logic analyzer connected to a debug port. And yes, I'm enjoying every minute of it. Welcome back to Cloud 42. I'm James. Well, as you know, I am in the process of building a CNC controller using a Centroid Acorn and a Centroid Ether1616 I expansion board. And I had it pretty much all together, and I was getting ready to make a video to show it off to the world, and it didn't work. No matter what I did, I could not get the computer to connect to the I/O expansion board. It just acted like it wasn't even there. I spent a bunch of time troubleshooting it, and I ultimately was able to solve the problem and get it to connect, but it turned out to be something really subtle and kind of interesting. I wasn't actually planning on making a video on this, but I put the question to my viewers, and you have all spoken. The answer was overwhelmingly yes. You want to see it? So this is that video. So if you haven't seen the previous videos, this is the box that we're building. We've got the Acorn CNC controller, and down here is the Ether1616 expansion board, also from Centroid. And these are both connected to an Ethernet switch. So there's a network switch down underneath the Acorn board here, and that comes out to the port here, and this goes to the network jack on the computer back over here. So when we power up the software, it should find the Acorn board, and it should automatically find and detect the Ether1616 expansion board. Let me just go ahead and start this up and show you what is happening. So establishing communications with Acorn, and that pops up. That seems perfectly happy, though when I look down at the lights on the Ether1616 board, it doesn't appear to be connected. If I go over here into Utility, Acorn Wizard, let this pop up. I can go to input definitions, and we have the integrated inputs that are on the Acorn board, and over here for the Ether1616 expansions, it just says auto detection did not find any Ether1616 expansion boards. And then they have a pointer off to the documentation. So this is the problem. It is not finding this board. And this is the task that we need to troubleshoot today. Now, it's going to be really, really hard to work on this with the board buried down here in the box. So let me dig it out, get it outside of the enclosure and onto the bench where we can work with it properly. Okay, I've got the board extracted from its home in the box and out here on the bench where we can work with it and see better what's happening. I've got a separate 24-volt power supply connected to it, and I have a network cable connected to it that goes back into the switch in the box. So this should be happy, and in fact it's powered up and we get this single light. Let me just power cycle it here. When I power it on, the lights chase around for a minute and then go to that single bar. And my understanding is that that's correct. And if I unplug the network cable, you can see it starts flashing a 2, meaning that that's the error code for not seeing the network connection. Plug the network cable back in, it goes to that single bar. And my understanding is that is the correct behavior. And then when we start the software, it should automatically discover this board on the local network, and the lights should start moving again. So let's start CNC12. It's talking to the Acorn, and I know it is because I heard some things in the box click. Now that's up, seems happy, but no change here. Let's open the wizard. Input definitions, yep, sure enough, auto detection did not find the Ether1616. Okay, so I think the first thing I want to do is try to figure out, is the board actually booting and running, and is it working properly? Because I've never actually seen this thing connect to anything. So, you know, for all I know, I mean, it's got a test sticker on here that's handwritten, so I believe they tested it. I believe it was good at one point, but I have no idea if it's working properly now. Let's see if we can figure out some basic tests to try to determine the status of the board. Now, the first thing I want to check, just because if I don't, I will hear Dave Jones's voice in my head forever asking me why I didn't, and that is I'm going to check the voltages. Now, I know that This board takes 24 volts in, but I can see that it's got DC to DC converters on it to step that down to lower voltages. So let's just start by checking the input voltage, make sure we don't have a power supply problem. And there, 24.24. Let's see, can I put this where you can see it better? 24.24 volts. Make sure that's positive. Now, I've looked these over carefully and I can see that this is a 3.3 volt voltage converter and these are 5 volt converters. Now, I know that makes sense because these are the relay board outputs and the relays take 5 volts. And so I suspect that the onboard microcontroller logic takes 3.3. And I can see a bypass capacitor down here next to it. So let me just take the voltage off of that capacitor. And I see 3.3 volts almost exactly. Let me check this one over here. 5.02. And this one over here, 5.04. Okay, so the voltages all look good. Now, I happen to know that the way this works from reading the manual is that there's an address jumper down here, and I have it on A0, and so I know what address it's supposed to be. Well, let's just try pinging it and see if it responds. So I know it's supposed to be at 10.168.41.2 should be the Acorn board. And yes, I'm getting responses from the Acorn board, and let's try .3, which should be, if this is on A0, should be the address of this board. And I'm getting responses from the Ether1616 board. So I know that the power supply is good. We've seen activity on the light here based on whether the network's plugged in or not. We can ping it over the network so we know that the microprocessor is running and it's actually happy. Well, we don't know that it's happy. We know that it's actually running, but for some reason we're still not discovering it and I'm not sure why. Now, I can't help but notice that there is a port here on the board labeled serial. This has got to be a serial debugging port. I've got a logic analyzer. Let's plug it in and sniff the port and see if it's outputting anything that might give us a clue as to what it thinks is happening. Now, I've got my Salier Logic Pro logic analyzer here, and what I'm going to do is hook up to this serial port and see if we can figure out what the protocol is and see if it's outputting anything useful. And you know, if I had to get a serial port adapter and guess voltages and protocols and connect it, it would be pretty complex to do this, but with a logic analyzer, it turns out this is really easy. The only thing I really need to know about this pin, or about this port, is I need to find a ground pin so that I have something to reference this from. So I'm just going to use my multimeter here in continuity check mode, and let's see, the 24 ground, yep, that goes out to here. So now I just need to figure out a pin that's connected to ground. And there it is. So this last pin down in the quarter is a ground pin. Now, it was the last one I checked, so I know there aren't any others, but it wouldn't really matter. So I will connect up the ground input from my logic analyzer to that, and then I will just connect all of the rest of the pins to inputs on the analyzer. The order doesn't matter at all because I don't know what the protocol here is anyway. I just need to connect one wire to every pin, and then we'll power it up and we'll see if any of them are talking to us. Okay, it's 10 pins, so I've got 1 ground and 9 inputs. So over here in the software, I will set this up so that we're listening on the first 9 inputs. I'll sample at, I don't know, 25 megasamples a second. I have no idea how fast this needs to be, but we will just start a capture. Okay, now I will plug this in, power it up, and I did see a burst of data go by. Okay, let me stop this, and let's go back and see if we can figure out what that was. So what we're looking for is something that looks like serial data. And I'd say these are identical. Those look like serial data. This doesn't necessarily. Let's just pick this one right here. So channel 1. And let's go into analyzers. But first, let's go in here and see if we can figure out anything about it. So if I kind of come in here and hover over it, I'm seeing a width here. It's showing 114 kilohertz. So I'm guessing that's, I think a good guess on this would be this is 115K baud. So let's just go have a guess. Let's turn on analyzers. Async serial. Let's take that from channel 1. And let's do the standard 115, 200 on the bit rate. Why can't I? 115, 200 baud, and let's just try 8 bits, 1 stop bit, no parity, the least significant. Let's try all the defaults, save that, and see if we've got data. And we don't. That's all looking like a framing error. Let's look at this in console mode. Yeah, that doesn't look right to me. Let's try something else here. Edit that and try inverting it. Ah, look at that. I see actual data in here. Okay, so let's just start a new capture and we'll reboot the thing and see what we get. Start a new capture, plug this in, and it looks like we get Ether1616 Ethernet IO card, status jumper01, which we know it is. There's the MAC address, gateway 41.1. There's the IP, 10.168.41.3, we knew that, and port 7855. Now, the interesting question is, if we try to connect to it, does it output anything? So while that continues to run, I'm going to go ahead and start up the CNC software, let it connect. See what happens here. Okay, and it's telling me that my MPG pendant is disconnected because I needed the serial port for the logic analyzer. That's fine. Let's go into the utility, Acorn Wizard. And sure enough, it definitely is not found. Let's get out of here and see if we got anything else. And we did not. We did not get anything else on the debug port. So whatever's happening, if this board is hearing from the computer at all, it's certainly not outputting anything on the debug port. So what do we know? What have we learned? We know that the board is booting. It's listening on the right address. We were able to talk to it on that address, and it seems perfectly happy. I'm not seeing any errors in here. I'm not seeing any indication that it thinks anything is wrong. So I think the board is probably just fine. We probably should turn our attention to the computer side of this and see if we can figure out if there's something going on that side. Okay, I pulled out my laptop here and installed the CNC12 software on the laptop, and then I have an Ethernet dongle here to USB-C plugged into the switch so that we should be able to run the control software on here. I just want to rule out that I want to find out if it's an issue with this computer. If this computer works, then I know it's something to do with this computer. If this one doesn't, then I know it's probably something to do with the board or something else I haven't looked at yet. So let's go ahead and fire it up here and see what happens. Here, click. Ah, look at that. A change in the Ether1616 configuration has been detected. There are 1 devices detected and 0 configured. So it found it. You want to accept the current configuration? And I will say yes. Okay, it found it. I hear the board clicking over there. I don't hear it starting. Let me try resetting the board and see if that makes a difference. Now, I'm honestly not sure why this is not fully starting and connecting, but the fact that it did recognize that the Ether1616 board was here is a good sign. That tells me that the problem with the discovery is not with that. It's probably with something else here on the laptop. I honestly spun this up earlier today and it actually worked. So I'm not sure exactly what's wrong at the moment. We're just going to forget about this now. The point is that using this laptop connected up to the network, it actually did find it. So we know that the problem's not with the board. The problem has something to do with this computer. And one of the things that I can try is, this is just a USB Ethernet connection. I could go ahead and just hook this up to this computer and see if this computer works with this external Ethernet card, and that would tell us that the issue is with the Ethernet on board. Let's give it a try and see. Okay, I've switched this all out. I got the laptop out of here, and I've hooked up the same network adapter to the USB port on this computer. I disabled the onboard and reassigned the IP address to this USB network adapter, and let's try it again. And look at that, it just popped up saying that there was a change detected and there is one device. You want to accept it? Yes, I do. And I know the pendant's not plugged in because I hooked it up another USB device. Okay, so let's go look at utility here. Acorn Wizard. And input definitions, and sure enough, there they are. And output definitions. So it found the Ether1616 in this configuration. So what that means is that this computer is just fine. It found it with this external USB network card, but it's not finding it with the internal card. And I'm not sure why that would be. Why don't we bring up a packet sniffer? Let's put this back on the internal card, and let's bring up a packet sniffer and actually look at the traffic and see if anything stands out, see if we can see anything that makes any sense. Okay, I've installed a packet sniffer on here. It's called Wireshark. This is open source software. If you're interested in networking, this is a fun tool to play with. And it's going to come up here, find all of my connections. Ethernet 2 is the one I care about. Right click on that and start a capture. Now this is going to capture all the packets going to and from that network address. So let me go ahead and start the software. Establishing communication with Acorn, and it says there are now 0 devices. Okay, well that's because it didn't find it this time. And yes, I do want to accept that, and no, I understand my MPG is still not plugged in. Okay, and let's go and just confirm that sure enough it's not there. And sure enough it's not, now that we're back on the original network adapter. So let's stop this capture and take a look at what it says. Let's scroll up here to the top and see what happened initially. So we've got some SSDP stuff. This is just Windows. Some MDNS stuff. This is just Windows. We've got some ARP packets, and then we've got communication from 10.168.41.1, that's this computer, to 10.168.41.2, that's the Acorn, and then here's a packet coming back from the Acorn, and a bunch of back and forth traffic to the Acorn. What I don't see is 10.168.41.3. I do see some ARP traffic right up here at the top. And this, I think, is what has our clue as to what's going on. Now, if you don't know what this is called a book. This was used in the before times to encode information on slices of dead tree. This particular book is about TCP/IP, or the internet protocols. And this was published back in probably 95 or thereabouts. And this starts out with the history of the internet. By the way, this is what the internet looked like in 1989 and 90. Now, the whole point of the internet is in the name. Internet, short for internetwork. And the point is to take a whole bunch, in this case, this was a whole bunch at the time, of course now it's millions or billions, of individual networks and connect them together in a way that you could route traffic from network to network and get from any place in the internet to any other place in the internet. And so in order to do that, they created an addressing standard called IP addresses. An IP address stands for Internet Protocol Address, and it's 4 8-bit numbers. So 169.138.1.1, might be the IP address of your cable modem. And in order to actually deliver to those addresses, though, there's all kinds of protocols that allow packets with a destination address to be routed from network to network to network. But once they actually arrive at the final network where they need to be delivered to a particular computer or a particular device on that network, you have to map that IP address to the actual physical address of the physical network. And that is something that's handled by a protocol called ARP. And it stands for Address Resolution Protocol. And the way ARP works is you don't know what's on the local network. You don't know the physical addresses of what's on the local network. So you have to send out a broadcast to ask. So if you got host A and it wants to talk to host B by its IP address, it will send a broadcast packet. It's an ARP packet that goes out onto the network, and it goes to every node on that network saying, hey, I'm looking for this address B, who has it? And everybody else will ignore it except for B, and B will respond back and say, hey, that's me. Here's the physical address of my host. And in the case of Ethernet, these are going to be 6-byte addresses, usually expressed as hexadecimal. So when the board is trying to figure out, okay, how do I talk to the Acorn? When the computer wants to talk to the Acorn, it'll broadcast and say, what is 10.168.41.2? Who has that? And the Acorn will respond and say, that's me, here's my address. And from that point on, the computers can talk. So that's what we're seeing in the network sniffer, is that ARP traffic trying to map from the IP addresses down to the physical address of the device on the network. So if we look at the ARP traffic here, there is something that looks a little bit odd to me. So this second packet here makes total sense. It's ARPing out saying who has 10.68.41.2. This is because this machine knows that it needs to talk to the Acorn at 10.168.41.2. It doesn't know the physical address. So it sends out this packet saying who has 10.168.41.2 and tell 10.168.41.1. That's this computer. So and that's going out to the broadcast address saying anybody who's got this, respond. And then we get a response from 10.68.41.2 saying I am at, and then it gives the address here, 80 F5 B5 F5 61 AB. So that's exactly what we would expect, followed immediately by sending a packet to that address. Now, of course, it's really sending it to the physical address right here on the wire 80 F5 B5 F5 61 AB that it just learned from the ARP packet. So that all makes sense. What doesn't make sense is this first one here, saying who has 10.168.41.255. So this address ending in 255, the last 8 bits are all ones. This is a broadcast address. So what the computer is trying to do is figure out how to send a broadcast packet to every host on the network so that it can identify the Ether1616 board. This is one of the things that they told me in the support forums, is that it sends out a UDP broadcast packet. But it shouldn't need to ARP to find out the broadcast address, because it knows if this is a broadcast address, it knows that this should be on the local segment. It should just send it to the Ethernet hardware broadcast address, which would be all Fs. And so I don't know why it's ARPing for this. This doesn't make any sense. This has got to be some kind of a defect or a bug or a weird configuration or something. So let's go take a look at the network driver on this machine and see if there are any settings that might be able to affect this. I don't really know. I've done some searching on the internet looking to see if there are some issues with the network cards in here. And I have seen various people saying, oh, go in and change these power save settings, go in and change stuff like this in the card for better gaming performance. So let's just go see what's in there and see if there's anything that makes sense. So the Windows key, Device Manager, and let's go find network adapters. So here's the network card, Realtek PCI Gigabit Ethernet Family Controller number 2. Right click on that, Properties, and let's go to the Advanced tab. There's a whole bunch of settings in here, and I have seen suggestions to turn off things like green Ethernet and power saving mode and things like that for, you know, better gaming performance. But I get in here, the very first thing in the list here is ARP offload. Now, I did a little bit of research to try to understand what this setting does. And what offload means in general is that instead of handling the functionality in the driver, in the software, actually run by the CPU in the computer, instead it offloads that work to the network chip or to the hardware. And so in this case, it's the Realtek PCI controller chip. Now, my understanding is that with ARP offload, the purpose in doing that is not really for performance. The reason is so that when the computer is in sleep mode and the processor is not running, the network hardware can still respond to ARP requests. So ARP offload is telling it to handle ARP in the network hardware. Now, if we turn this off, if we say disabled, then instead of handling the ARP in the network hardware, it will handle it in the software in the driver. Now, this is only done occasionally. This shouldn't be a performance issue, but it will definitely change the implementation. It's going to be running instead of handling it in the chip, it's going to handle it in the driver software. That will be a completely different implementation of ARP. And since we know that ARP is doing something weird on this box, let's try it. So, disable the ARP offload. And we should be ready to go. Let's try it again. And what do you know? It worked. There's a change in the Ether1616 configuration. One device is detected. And we'll go into Utility, Acorn Wizard. And there it is. Input and output definitions are all there. So let's bring up Wireshark again and let's actually watch this and see what it's supposed to look like. Shut this down first. Okay, and start this up. Okay, that's up. Let's go to Wireshark, stop this, and go have a look at what happened. And here we have exactly what we would expect. So we are ARPing here for 10.168.41.2. That's the Acorn board, and it is responding, and then we're talking to it. But before that, we had a UDP broadcast packet that went out. So from 10.168.41.1 out to 10.168.41.255. Now there was no ARP. It didn't ARP for this. It knows that that is the broadcast address, and so if you look at the Ethernet frame, it actually sent it to the broadcast Ethernet address, and of course it got a response from 10.168.41.3, which is exactly what we would expect. So it found the Acorn board, and in fact, if you look over here at the display, you can see that it is cycling. So while the software is running, it's cycling, meaning it has connected, which means we've solved the problem. This whole thing came down to a bug in the hardware implementation of the ARP protocol in the network hardware in this computer. Now, there's a reason why if you go to Centroid and you buy an Acorn board, they will just tell you to buy a specific computer. In fact, they sell computers that are pre-configured, or they'll tell you to buy a specific Intel NUC. And the reason they want you to do that is because of stupid stuff like this. But as it turns out, we were able to find it. We were able to fix it. This is working, and I think we're ready to put this thing together and do some bench testing with some real motors. And we'll work on that next time. If you enjoyed this video, give it a thumbs up. Feel free to subscribe to the channel and leave me a comment. I'd like to know what you think. Thank you for watching.